ignore this because we came up with a nice one, is writing algebraic expressions. Okay, so this is sort of the beginning stages of working with algebra, understanding that we can take a word sum or maths that has been written into words and write it as a mathematical statement, write it as an algebraic expression. Remember, I've said to you that algebraic expressions are like math sentences. We have words that are terms that make up our math sentence. And so these sentences actually give us information about our problem or a problem that we're working with. Alrighty, so let's have a look at an example. I think it's going to be easier for me to type this example. Apparently it's not going to be easier. Has X. I'm going to write it because apparently typing is not my forte tonight, and that's cool. So let's have a look. I'm going to use Zintle to start off with. So Zintle has X sweets for lunch. Not a very healthy lunch, but it's fine. Senzo has 3 less sweets than Zintle. And Bonolo has 3 times many sweets as Senzo. All right, guys, so this is my word problem, for lack of a better description, but this is basically me describing in words a scenario. Okay, so we need to be able to, when writing an algebraic expression, we need to be able to take those words and put them in a mathematical sentence. This is like an English sentence right now. We are doing math, so we want to change our language to math. And this is something that a lot of people struggle with. We often struggle when we've got a lot of words in maths, which is understandable. But what we need to remember is maths is like a second, third, fourth language. We need to learn how to be able to speak maths. All right, so I would ask you a whole bunch of questions based on this whole scenario. The first of which would be to write an expression in terms of X for Senzo and Bonolo. Okay, so what we need to remember is that based on my initial sentence, all of these, and this is why we say in terms of X, the expressions that I'm going to write down need to have X somewhere in it because they all relate back to how many sweets Zintle had. So if we now go and have a look and see how we can write down an expression, we know that Zintle has X sweets. Okay, that was the information that we started with. That's sort of our foundation starting point for this question. We now want expressions for Senzo as well as for Bonolo. Let's go back to our question and see what we were told. We were told that Senzo has 3 less sweets than Zintle. So grade 8 on the chat for me. How would you write and what would the expression be to say how many sweets Senzo has in terms of X? What would that look like if we wanted to write down an expression to tell us that Senzo had 3 less than Zintle? Let's see. Okay, remember right now I'm just asking for Senzo's expression. We're not on Bonolo yet. We just want for Senzo. So how would I write that Senzo has 3 less sweets than Zintle? Good, guys. Okay, so really importantly here, the first thing is whenever we're working with less or whenever we are working with a subtraction, we need to be very, very careful of the order in which we subtract terms. So we know Senzo has 3 less than Zintle has. So Zintle has x, 3 less than that would be x minus 3. If we said 3 minus x, what we're basically saying is that Zintle has 3 sweets and Senzo has x less sweets than 3. So we just need to be very, very careful of our order. Remember, if you are adding values or terms, order doesn't matter. 2 plus 3 is the same answer as 3 plus 2. But when you are subtracting, we do need to get the order correct. 1 minus 2 does not give us the same answer as 2 minus 1. And so order of subtraction is very important. So 3 less than Zintle. Zintle has x. 3 less than that, x minus 3. Alrighty. So we've got an expression for Senzo. We now need one for Bonolo. So let's go back and read what information we were given. It tells us that Bonolo has 3 times as many sweets as Senzo. So if we know how many Senzo has, we can now go and work with that to get Bonolo's expression. So again, on the chat, what would the expression look like for Bonolo's number of sweets if we know that Bonolo has 3 times as many as Senzo? Remember, you're going to probably need to use some brackets because if we are multiplying multiple terms, we need to remember that everything should be multiplied. So I'm liking what I'm seeing so far. I will show you 2 versions of the answer, and I wouldn't really mind which you chose to give. I would give what most of you are giving me right now. Good. Good, guys. So we know Bonolo has 3 times as many as Senzo. If Senzo has x minus 3, we want to times that amount by 3 to get 3 times that. Now, I would be happy with that. That's probably where I would stop as well. If you wanted to simplify this and distribute that 3 into the bracket and write this as 3x minus 9, that is fine. It's exactly the same answer, just simplified. So you could give me either one of those. I would probably stick with 3 times the bracket, but it really doesn't matter. Okay, but what we have done is we have written down expressions for all 3 of them. Zintle I gave you, so we didn't need to stress too much, but we have now got expressions for both Senzo and Bonolo. All right, so there's sort of 2 types of questions I can now go and ask you. And obviously I haven't left myself enough space. As you guys know, I'm not capable of leaving myself enough space when we do these. So, you know, whatever. Let's just move this. So like I say, 2 types of questions I can now go and ask you. One slightly easier than the other. So let's start with the easier one. So I could say if Zintle had, sorry, that's a weird looking Z, it looked like a 2. If Zintle had 15 sweets, how many sweets did Senzo and Bonolo each have? All right, so what I'm doing here in the first sort of type of question I could now ask you is I'm giving you a value. So remember, we said that Zintle has X sweets. I am now telling you Zintle has 15. So what I'm actually giving you here is I'm telling you what the value of X is. I'm telling you that X is equal to 15. Because we've got expressions for both Senzo and Bonolo in terms of X, we can very easily go and work out how many sweets each of them had. So on the chat, guys, what I want you to do for me is I want you to tell me how many sweets Senzo has and how many sweets Bonolo has. If you want to just use S and B, that's okay. But how many sweets does Senzo have? How many sweets does Bonolo have? Obviously, remember, you need to label your answers. I need to know who's who. So like Lwandle's done there, if you want to use S for Senzo, B for Bonolo, that's cool. But how many do they each have? Okay, I'm giving everyone a chance to give it a try. Good, grade 8. Okay, so what we need to remember is that if I give you a value for x, you can substitute. So Senzo's expression we know is x minus 3. We now know x was 15, so 15 minus 3, which tells us that Senzo had 12 sweets. If we now move on to Bonolo's number of sweets, again, we know what the expression was, 3 times x minus 3. We know x is 15. We know 15 minus 3 is 12. And then we can go and multiply that. So 3 times 12 gives us 36 sweets for Bonolo. So this is the one way we can ask these questions, whereby I give you a value and you need to go and solve for the other two expressions. So I would say how many sweets or how many shoes or how many pens or whatever do each of these people have. All right, so that's a sort of easier one of the two options. I'm just going to move over. I will come back to this. Don't stress for you to screenshot. But this sort of second type of question I could lead you on from once you have your expressions is something like the following. 1 minute. Let's hope my maths is relatively decent here. If altogether they have 113 sweets, how many sweets did each child have? Okay, so this is sort of the second type of question I could ask. I could give you a value for the variable x, and then you just substitute. The other way I could ask this is I could say if altogether they now have 113 sweets, how many sweets do each of them have? So if we just write down our expressions again for ourselves, just so that we know what we're working with, we know that Zintle has x sweets. We know that Senzo has x minus 3 sweets. And we know that Bonolo has 3 times x minus 3. So I want you to have a quick think. And then on the chat, I don't want you to tell me an answer. I don't want anything. I just want, no, actually not on the chat. Let's say raise hands, because I think it'll be easier to be able to say it out loud. So have a think. And then if you want to raise your hand to just explain how you would now go and work it out. I don't want an answer. I don't need you to work it out for me. Just tell me how you would approach this. So again, I'm telling you that altogether, they've got 113 sweets. I want to know how many sweets Senzo had, Zintle had, and how many Bonolo had. So all I'm asking right now is how would you approach this? What would you start to do in order to get that answer? I know you know this, grade 8. If you're not feeling brave enough to raise your hand, you're welcome to type in the chat how you think you could go about solving this. You don't have to raise your hand. You're welcome to use the chat. Okay, let's simplify this, grade 8. What would I have to do, or English, what would I have to do with all of their number of sweets to get 113? Would I have to add their number of sweets? Would I have to times their number of sweets? What operation would I have to do to get the total number of sweets that the three of them have combined? So let's start with that on the chat. What operation would you use? Would you add them, subtract them, times them, divide them, raise them to an exponent? What would you do to get the total number of sweets? I'm not doing anything until I see an answer because I know you know this. So to get a total, what do we do? What operation do we use to get a total? Thank you, Shumi. Thank you. Alrighty, so guys, if you want the total of something, we add. That's the operation that we're working with. If I said the total number of chocolates that you ate today, you would add the number of chocolates. The total number of blades of grass on the hockey field or on the rugby field, you would go and add all the number of blades of grass. So when we want a total, we are adding. So what I'm giving you here in terms of the 113 is a total value. This is giving us the number of sweets in total. And so what that means is I can set up an equation. And yes, we haven't done equations yet, but this isn't too tricky, so we're going to try it. We can now set up an equation. If I take the number of sweets Zintle has, plus the number of sweets Senzo has, plus the number of sweets Bonolo has, I must get 113. Now we've got expressions for all of these. We know Zintle has X sweets, Senzo has X minus 3 sweets, and Bonolo has 3 times X minus 3 sweets. So because we had those expressions, we now just put them into an equation and we can go and solve for X. Right, I'm going to do this with you just because we haven't, or we on Watobe haven't done equations just yet. So I don't expect you to know it, although some of you have probably done it at school. Remember, if there is just a plus sign in front of a bracket, what you actually have is +1 as your coefficient. Yes, you can distribute that, but it's not going to change anything. What is going to happen, though, in this third term is we need to distribute the 3 into the bracket. So our expression on the left-hand side is going to be x plus x minus 3. 3 times x is 3x. 3 times -3 minus 9. This is now where we need to start looking for like terms. So here I've got x terms. I also have some constant terms on the left-hand side, the -9 and the -3. So we're going to neaten up this left-hand side. X plus x is 2x, plus 3x is 5x. -3 minus another 9 gives us -12. So all I've done is I've neatened up my left-hand side. Now, if you remember your equations from grade 7, whenever we start to solve for a value, so here we're solving for x, we need to use inverse or opposite operations. So what that means is I want to essentially get rid of this -12, so I'm going to use the opposite. If I say -12 plus 12, it cancels out. But what I do on the left-hand side of my equation, I must do on the right-hand side of my equation. So what I now have is 5x is equal to 125. And once again, I don't want 5x, I want x. So if I want to get rid of this 5 times x, I do the opposite, I divide. But if I'm going to divide the left by 5, I must divide the right by 5. So if we now go and divide 125 by 5, we end up with 25. And so what we have is that x is 25. So we can now take this information and we can go back and work out how many sweets each of them have. Clearly, Zintle has 25 sweets. Let's go here. So Zintle has 25 sweets. Senzo has 3 less. Don't know what's happening. Let's see. Yeah, cool. Anyone want to? There we go. Senzo has 3 less. So Senzo has 22 sweets. Okay, you're going to have to just deal with my weird writing right now. And then we know that Bonolo has 3 times as many as Senzo. So what we could just do is just take this 22 and we could times it by 3. And that would give us 66 sweets. Now you can go and double check yourself, grade 8s. If you take all of those numbers and you add them together, so 25 plus 22 plus 100, try that again, 25 plus 22 plus 66, we get 113. And that makes sense because the total number of sweets that I gave you was 113. So you can always double check yourself by just adding your values together to make sure you do get the total that I gave you. All right, so grade 8s, this is definitely one of the tougher types of questions that I could ask you. We would classify this as a problem-solving sort of question, or at least a complex question. So this shouldn't necessarily be super easy. And if it is, that's absolutely fine, obviously. But this is definitely the type of question we could ask you. And so you need to be able to deal with it in an assessment scenario. Alrighty, so what I'm going to do is, I don't know how small I'm going to be able to make this. No, that's good. So what I'm going to do is that I want you to screenshot those questions that we had a look at. And while you're doing that, if anyone has any questions, now is the time to raise your hand and ask me. I've done something weird with my pen, unfortunately, today. So my writing is going to get a bit dodgy. But we're going to work with it. Don't know what's happening. Don't know if you can still see my screen. Let's hope so. Right, any questions? Okay. Good, guys, well done. Alrighty, so I hope you've all got your screenshots. Whilst it's very important for us to be able to write expressions, obviously we also need to be able to work with expressions. So if we have a look at the second example here, I have now given you an expression of and I am asking you a bunch of questions. Now, I've said this to you before, I'm going to say it again. This sort of question is how we like to test your terminology. So this is how we like to test whether or not you know what certain words mean in maths. So we've been given the expression 2x plus 10 times y plus 2 plus y plus 3 divided by 3 plus 1. All right, so there's a lot going on here, and we generally do this. We give you an expression that's got quite a bit going on, and we now need to go and answer a couple questions. The first of which is asking us how many terms are in this expression. So would someone like to raise their hand and tell us or remind us what a term is? How do I identify terms? Like, how am I going to answer this? I can see some of you already putting answers in the chat. That's cool. Wandle, how do we identify terms?
Afternoon, ma'am.
Hi.
I don't know. So ma'am, the way you the way you identify a term, I think is, and a term is basically a part in an algebraic expression.
Good.
So you identify terms by seeing that they are separated by plus or minus signs.
Good. And which plus or minus signs do we ignore when identifying terms?
Plus or minus signs, when we ignore.
Yeah, so we don't, so like I won't necessarily
Oh, the
consider
ones in the
kids-
brackets. Yeah. Now I remember.
Good. Okay, so guys, Luandle has beautifully explained that. Firstly, terms make up an expression. They are the parts that make up an expression. Remember, I've said to you, an expression is like a sentence. Terms are the words to that sentence. Right, then Luandle has also told us how we identify our terms. Terms are separated by plus and minus signs, but we ignore the plus or minus signs inside brackets or inside fractions. So the only plus signs or minus signs that I actually care about are these ones that I'm highlighting in yellow. The other two is either in a fraction or in a bracket, and I don't care about those, at least not for term identification. What this does is this identifies my terms for me. So 2x is my first term. The 10 times the bracket y plus 2 is my second term. My fraction of y plus 3 over 3 is my third term. And then that plus 1 right at the end is term number 4. So I have got, and like I say, you guys beautifully identified that for me in the chat. I have got 4 terms in this expression, and I've identified that through my plus and minus signs. A little bit of a hint, guys. Your term should either be something by itself, so 2x, 1, nothing really going on, or there should be multiplication or division happening. So like in term 2, we have distribution. In term 3, we've got division. That's sort of like how you should know you're on the right track with your terms. Right, so we now know how many terms there are. Remember, it's super important to identify your terms, because if you need to start simplifying an expression, you need to know what simplification to do in each term. Right. Oh, question number B is asking us to write down the coefficient of x. So again, hands up. Who would like to explain to me what a coefficient is? Gilwe? Oh, English. Leah Gilwe? Sorry.
Hi, ma'am.
Hi.
Ma'am, a coefficient is when a number has a variable next to it.
Good. And what is the operation between the number and the variable? I'm going to be honest, I don't know if you answered. But now I seem to have lost you. All right, no problem. Very importantly, guys, as Leah Gua has said for us, a coefficient is the value or the number in front of your variable. Now, a coefficient has got an operation of multiplication between number and variable. So if we want the coefficient specifically of x, we go up to our expression to our x term. All the other terms have y in it, so I don't need to worry about those. I now need to look at what number is in front of x. That is the number 2. So my coefficient of x here is 2. I am timesing 2 and x. That is the operation between coefficient and variable. It's a weird looking 2, but we're going to roll with it. Doesn't matter. Right, the next one that we'd like to ask you is, what is your constant term? So again, hands up. Who can tell me what a constant is? Chantal? There we go.
Ma'am, a constant is a term that will never change.
Good. Okay, so how would we identify a constant term in an expression? What would we look out for?
Ma'am, it doesn't have a variable.
Excellent. So guys, firstly, a constant is a value that won't change. It hasn't got a variable attached to it that we would then times or divide it by to change its value. So a constant term has no variable. So again, we go to our expression. We look at our constant term, or we look at the term that has no variable. We see that that is term number 4. Okay. Cool. And so we can see that our constant term here is positive 1. Please bear in mind that if this had been a negative in front of the 1, our constant term would be negative. Remember that the sign goes with its term. And so just bear that in mind, especially with constants and coefficients. That's sometimes where we trick you out or you get caught out. You don't put the sign. So if there had been a negative in front of the 1, your constant would be negative 1. All right, so those or that is how we like to test your terminology. What we also like to do is we like to give you values that we want you to go and substitute into the expression. Now, this is going to be quite interesting if my pen isn't going to work, but we're going to roll with it. So if I just rewrite this expression, and guys, I'm sorry, my pen doesn't want to work, and unfortunately, the only way I can get it to work is to restart my laptop, which obviously we can't do right now. So here's my expression. That's a y. We're just going to roll. It's all right. It's good enough. And I'm telling you that x is equal to 1 and that y is equal to 3. So I'm giving you the values of our variables. What that means is that every time I see a y, I'm going to substitute in a 3. And every time I see that x, I'm going to substitute in a 1. So this is now testing your ability to substitute. So what we would have here is 2 times 1, that's supposed to be a bracket, plus 10 times 3 plus 2, because y is 3, plus 3 plus 3 over 3 plus 1. So once you've substituted in your values, you can now go and work it out. Now, 2 bits of advice. Firstly, do it slowly, okay? If you do something funny, you're going to make a very silly mistake, and it means that you'll get the answer wrong. Second bit of advice is that use your calculator to check yourselves, okay? Yes, it says without a calculator, which means you must show all of your working out, but check with a calculator. You have a calculator, use it to help yourself. If your calculator and your answer are 2 different things, you've done something wrong somewhere and you need to double check yourself. All right, so if we do this without a calculator, we show all of our working out. 2 times 1 is 2. In the bracket, 3 plus 2 gives us 5. So 5 times 10 is 50. So we've got 2 plus 50. In the fraction, we've got 3 plus 3, which is 6. 6 divided by 3 is 2. So the mistake I made earlier was I said 3 divided by 3 was 3. So again, silly mistake. Plus, let's attempt that again, plus 1. 2 plus 50 is 52. Plus 2 is 54. Plus 1 is 55. So the value of our expression if x is 1 and y is 3 is 55. Okay, so being able to substitute is so important. And the idea of substitution, guys, becomes very important as you move on with algebra. So we need to be able to substitute, and we need to be able to remember things like when am I timesing, when am I dividing, etc., etc. All right, so take your screenshots of this one. If anyone has any questions, now is the time to raise your hand and ask me. You guys have done nicely, and I did start you off with quite a tricky expression to work with, so I think you're deserving of a brain break. We're not going to spend too long on our brain break, but you know the drill. We'll get there. Okay, so screenshots. If you have questions, please ask. Otherwise, I'm about to scroll to your brain break. Okay, no questions. Good, guys, well done. So this sort of question, all of you should be able to do. This is one where it's nice, easy marks as long as you've learned your stuff. Righto, so here's our brain break for the day. You guys know the drill. I want the value of the very last equation over here. Please be careful of where you've got doubles, but I want to know what is the value of this very last equation. I will make it bigger for you guys now as well. Just thought, you know, if you wanted to appreciate the joke. And again, we're going to wait for the answer. First person to get the answer is going to explain it to us. Okay, here it is a bit bigger. So these things in the top row are polar bears. This dark gray one is a koala, and then you've got the monkeys in the last 2 equations. So we've got polar bears, koalas, and monkeys. And I want the value of the last expression there. Senzo, I use a laptop. Are you trying to help me with my pen situation? I could turn it into like an iPad, but then my camera goes to my ceiling and like it's not interesting at all. But maybe it might work actually. Let's see. I'm going to turn my camera off. Let's see what happens. I've never actually thought to do that. Shows you how well my brain works sometimes, guys. Ooh. No, it still doesn't like me. Oh, wait. Maybe I spoke too soon. I think I spoke too soon. Ooh. Okay, sorry. There you go. Brain break is back. Senzo, you might have just solved this problem for me. Let's see how we go. We're gonna work with it like this. Let's see what happens. Alrighty, Renewway. I think I agree with you. So if you want to raise your hand, you can explain to us how you did it. Okay, let's hear it.
Hi, ma'am.
Hi, how are you?
I'm fine. So, ma'am,
Renewway, try and go a bit closer to your microphone. I can't quite hear you.
okay. So, ma'am, for number 1, I said 24 divided by 3 because
Good.
the base are 3. So, equals to 8. Then I said 8 plus 8 plus 8, and then it gave me 24.
Good.
And then, ma'am, I said 8 plus 8. Then I got, sorry, ma'am. I said 8 plus 8 equals to 16. And then I said 8. And then, yeah, okay. And then I said multiply by 9. And then equals to 80.
Okay, good. So guys, I'm just going to quickly stop you there. Renewway, you're doing really nicely though. So please don't panic. You're explaining this beautifully. Remember grade 8, you need to apply BODMAS. So you need to do the multiplication first, which gives you 72. Yeah, 72. And then you would add that 8, like Renewway said, to get 80. Okay, Renewway, you can carry on.
And then, ma'am, I said it is 9. And then I said 10 multiplied by 10, then equals to 100. And then I said plus 9 equals to 109. And then because, ma'am, the base are 2, I said 8 plus 8 equals to 16. And the monkeys are 2. I said 10 plus 10 equals to 20. Then I said 16 multiplied by 20 equals to 320. Then I said plus 9 equals to 329.
Excellent. Well done. So guys, again, Renewway applied that BODMAS. Remember, you have to times first. So 320 is 16 times 20 plus 9 is exactly 329. Unfortunately, my pen was not working, so we're now back to the mouse, but we're fine. Renewway, you explained that beautifully. Well done. Alrighty, guys. So that's how you do that brain break. I hope we all understand. I hope we all got it. And remember, and Yolanda tells you this all the time when we do these brain breaks, this is an example of algebra. Yes, we're using polar bears and koalas, but I very easily could have used X, Y, and Z. All right. And so this, as I constantly say, is algebra with pictures, but it's algebra. And if you can do these brain breaks, you're going to be okay for algebra and for solving equations. Right, grade 8, excellent, well done. Let's simplify some expressions here. So because you guys have just been so on it, what I want from you is I want you to try these first 2 for me. Not going to say anything. I want you to try. Remember, when we are simplifying expressions, the goal is to add our like terms, to simplify our terms, to get a much simpler looking expression. So I want you to try these 2. Remember, you need to write it down so that when we do corrections, you can correct your work. In the chat, I want you to label your answers A and B, please, so that I know which is which. I'm going to give you 2 minutes. Let's see how we go. And then we will look for it. So remember, I said I'm not going to say anything. And then I always end up saying anything, but it's fine. Remember 2 things. Like terms. I'm mastering this mouse writing skill. Like terms. And secondly, you need to remember your order of work. So when I say order of work grade 8s, I mean BODMAS. Okay. I look like a primary school child learning to write, but it's okay. It's beautiful in its own way. And we can all read it. Okay. Here we go. Right, so like terms and order of work, those are the 2 things I want you to remember when you try these 2. Remember, number your answers, A and B. Do it on your page or in your book first, and then give us the answers. I also just want you to take note of signs. Remember, whenever we've got a negative somewhere, we always need to be careful that we are taking it into account. If everything's positive, we should have no issues. That the second there's a negative, we just need to make sure. Please make sure you're also adding or subtracting, so simplifying all of the like terms. If you've left some unsimplified, unfortunately, you have not fully simplified the expression. And the question does say, as you can see, that we need to fully simplify. Good, Labanzi, you're on the right track, so you're nearly there. Add those constants, and then you got it. But well done on your X terms. Very nice. Okay, I'm liking the answers for A so far. I've only seen 1 answer for B so far from Shumi, and very nice. Keep it. Oh, sorry, Leo Gilway, well done. I also saw your answer there. Apologies. You did them together like we like, so well done. Okay, grade 8, so let's have a look. So question 1, there's no multiplication or division, so we just want to identify our like terms. So we've got 4 X terms, and remember in this last term, if you want to, you don't have to, but if you want to, you are welcome to write in your coefficient of 1 to the X, so that when you simplify, you remember that. So we've got a whole bunch of X terms, but we also have our constant terms, and that's what Simone put there on the chat, hopefully to help you. So when we now go and add these, if you want to remember, you're welcome to write your terms together. So you're welcome to write your like terms all grouped together so that you know exactly what you're adding or subtracting, and you're just going to deal with beautiful handwriting here. So there are all my X terms, and then I've got my constant terms of 7 and 9. If we add our X terms, 2X plus 3X is 5X, 5X minus 2X is 3X, 3X minus X is 2X. If we add our constants, 7 plus 9 is 16. Now guys, remember, you always double check. Do you have like terms? No, I don't. So that is my final simplified answer. Once I've dealt with all of my like terms, I'm done. Right, question B is a little bit trickier because now you've got multiplication as well as plus and minus signs. So this is now where we need to go back and identify our terms. So we identify our plus and our minus signs because that's going to separate our terms for us. What that means is that this 2 times x times 3 is term 1, 4 times x is term 2, and the negative 3 times 2 times y is term 3. Once you know what your terms are, you need to simplify each of them. So term 1, everything here is positive, and the reason I'm saying that is because we need to remember our SNV, signs, numbers, variables, when we multiply or divide. Everything's positive. So positive times a positive is a positive. If we move on to the numbers, there is that 1 in front of the x. So 2 times 1 is 2, times 3 is 6. And then we've got our variable x. Second term, positive 4 times positive 1 is positive 4x. Third term, however, we've got a negative sign. So a negative times a positive, because there's negative 3, positive 2, times a positive, we end up with a final answer that is negative. Yes, you've got a 1 in front of the y. 3 times 2 is 6. 6 times 1 is still 6. So we've got negative 6. And then we've got the y. And guys, what you need to remember is you have to identify your like terms. So here, what we see is that we've got x and x as like terms. But then we've also got a term that has a y in it. So that's a completely separate term. If we add those x terms, 6x plus 4x is 10x, and then we've just got our minus. Okay, that's terrible. I'm going to try that all again. 10x, and then we've just got that minus 6y that doesn't have any like terms to it. And that is our final simplified answer. So remember to always double check. Have you simplified or have you added and subtracted all of your like terms? Because if you haven't, it means that you haven't fully simplified, and that is our goal. We need to fully simplify. Right, so take your screenshots. If anyone has any questions, now is the time to ask. So guys, for the second one, what we want to do is we want to identify our terms. This is going to be wild, so let's go like this. Then we want to simplify each term. And then we want to add and subtract our like terms. If you can follow those 3 steps, you should be able to simplify any expression, any algebraic expression that I give you. Can't do it. Okay, there we go. Those 3 steps. Oh, I give up. Right, screenshots, questions. Okay, so guys, in terms of algebra, your basic things are sort of what we've done over here. You need to be able to add and subtract like terms, and you need to be able to follow your order of work. Order of work, when I say that, is basically following these 3 steps. If you can do those 3 things, you have followed your order of work correctly, and so you're simplifying your expression. We know that these can get more complicated, right? We've done this. And this is now, once we've spoken about exponents, we're going to start dealing with those more complex expressions that we need to simplify. But like I say, if you can do like terms, and if you can simplify your terms within an expression in order to get like terms, you are A-okay. Right, sweet children. So remember, today is Wednesday, which means that today is quiz day, not poll day. So you can see there on the chat, I have posted your quiz link. Please make sure you get it before you go anywhere. Remember, you do not have to do the quiz immediately. You are welcome to wait for this lesson to be uploaded, rewatch the lesson, make sure you're comfortable before you go do it. But do remember as well that we have done all of this. Nothing here is new. Okay,